So what can be taken apart can be put back together, but you've got to remember this. When you take a look at the properties of logarithms, the coefficients of each one of those logs in the properties is 1. So I can't do anything until the coefficient is 1. Because in this first one, I'm looking at the property that says that the log of m divided by n is the log of m subtract the log of n, and you notice that the coefficients here are 1. So I can't bring this back and use this property unless the coefficients are 1. So the first thing I have to do is I need to bring the 2 up, so it's going to be the reverse of property 3, so that this becomes then the log base 3 of u squared minus log base 3 of v. I hate using v's, but we use them a lot, unfortunately. And a subtraction, now this is property 3, and then a subtraction turns into a division, so we're looking at then log base 3 of, the numerator is the first term, denominator is the second. And then that's your final answer with it being brought back together. Now that's a product, a sum, and a sum turns into a product. So now we're using the one that says that a to the log base a of a product turns into the sum So again, I need the coefficients of the logarithms to be 1. And they are. That's good news. So that says, here's a sum. Sum turns into a product. So it's log base 2 of the first argument times the second argument, which is log base 2 of the product of these two. Now, to me, that's a perfectly good answer. But your book would write it this way. Log base 2 of x to the minus 3. Either one of those would be fine. Who cares? Depends upon what you're going to do with it, as to how you're going to leave it. If we're dealing with this thing in equation solving, this is probably a better form than this is.